Alright, so the tungsten core should be here somewhat soon, so it's time to get all the steel ready for the outside of the hammer. I'm going to use my vinegar here. I've got some old and I've got some new over there. I'm going to let it soak at least for a day or two, get all that mill scale off there, so when I'm ready for the tungsten core, I have everything I need. Oh man, look what showed up today. It's funny how small this thing is. I'm not sure how much it weighs yet. Geez, it's hard to even slide it, but not very big. Here's the scale model. You'll notice it's a good amount smaller. That's kind of hard to really see on camera, but it is smaller just to accommodate for the steel that I'm going to put on the outside, and my final dimensions will be very close to this, I believe. Let's get this bad boy on my ragged bathroom scale and see how much it weighs. That is 115.4. Interesting, I actually expected it to be a lot heavier than that. Alright, so I've got the steel out of the acid bath. I've got 2 pieces of 3/16, 2 pieces of 1/4 inch, 2 pieces of 5/16, and over here I've just got a piece of 3/8 and a piece of 1/2 inch, just in case I need it. I don't think I need anything that thick. Maybe for the strike faces on the end of the hammer, right here. But I'm gonna soak them anyway, just in case I need them. Alright, so just in case you're curious, this is an annular cutter. It's basically like a giant hole saw, but the flutes go all the way up the side. And a hole saw, they just get little tiny teeth on the ends. You can drill holes in, 1/8 inch, 3/16. But once you get over to about 1/4 inch, it gets real tough. You sometimes have to flip the material and everything because it just can't extract the chips, and they get stuck down the hole, and then no cutting happens. These can cut much deeper, and they leave a really nice surface finish in there as well. Relatively nice anyway. Compared to a hole saw, they're usually pretty jagged. If you notice, I have 2 pieces clamped together here. I wanted to drill the hole in exactly the same spot on both of these so I can use the hole for alignment on the hammerhead itself. Alright, so I'll use the dowel here to locate these 2 ends, and I've just been hand cutting and sanding and filing these pieces so that they'll all fit together. I think I've got the base part of the hammer down the hammer head. Now, these may look kind of half-ass cut, but I specifically didn't try to bevel these edges or anything because this angle from this piece to that piece creates this natural bevel, and that will give me room to weld into. I'll do probably at least 3 passes, and I'll build it up above the level that it's at right now, and then I'll grind and machine the whole thing off so I have sharp angles here. I've got all the pieces here for the head, so or rather just this part of the head. All the prep work and getting this core modeled out perfectly means that I don't really have to take any measurements. I know every surface is perfect, so I'm just using all these surfaces just to reference off of and building each piece so that it matches up perfectly. In the end, I think I'll have a very, very accurate hammerhead here. Just going to be a whole lot of cutting and hand fitting. I think I estimated or calculated 26 pieces of steel will go into this whole thing, just the head. Alright, we've tacked together most of it. I just have to do this final side here. You can see I'm keeping this very tight. There should be basically no gap. I don't want to risk this core from rattling, basically. This, if you think about it, at no point is it actually attached to the steel. I'm literally just making a shell around it. The handle going through and then the handle being welded to the shell will probably help, but I really don't want any sort of airspace. It's just going to be wasted space, number one, and number two, it could potentially rattle. I don't really think so. Not with this, the amount I'm clamping this now. Once this is all welded together, this is going to be very tight, I'm guessing. Okay, we're all tacked up here. Looks pretty good, I think. I just took the clamps off, so let's just see if this thing slides out of here. Nope. That's in there really good. I'm going to leave the wooden dowel in there most likely. It actually makes positioning the hammer in certain ways much easier, just due to the leverage, but I also want to make sure this thing doesn't shift, you know, when I'm flipping it or something like that, or I hit it with a hammer, it doesn't just shift slightly. I really need this hole to stay centered, basically, so that the handle will fit through there. So in the interest of time, for doing these kind of odd shapes, kind of trapezoidal, is it trapezoidal? I'm not really sure. I took the time and I hand filed one piece that's a perfect fit, more or less. And then I just cut out a bunch of blanks and I clamped the master to each one and then traced it out. And now all I have to do is just kind of grind and sand this to the shape, and I should have 8 nearly identical pieces. Alright, so we're all done with that. They didn't come out perfect, but I would say they're close enough. I'll center these in this slot. I'll tack weld all 8 of them on, and then I'll measure for this corner piece and we'll do exactly the same thing. We're getting there. Just the 2 strike faces on the end here. Probably go with 1/2 inch steel, I think. Alright, full disclosure, apparently I made a boo-boo here. I did a whole lot of welding on only one side, and during my last weld I heard a pop, and the tack welds holding this part on actually all broke, and you can see the gap is quite a bit bigger here now, so I'll have to go back around, cut off this weld, re-clamp this whole side in position, and then more substantially weld it in place before I start doing all these full welds. I think I even got a crack one there. I'll have to really go around the whole thing. These are just the tiniest little weakest welds. I thought it would be enough, but I guess not. Alright, got this thing all squared up with those clamps and everything, and much more substantial tacks this time. And I guess in doing the full welds, I'll just try to skip around a little bit better, not concentrate the heat in one area, which can cause, you know, the welds and the metal to shrink, and it'll put a lot of stress on the rest of it. So I'll work my way around it a little bit more and see how we do. Alright, well, I think we got this all welded up. I did anywhere between 2 and 4 or 5 passes on every seam. You can see I've really kind of built it up. Stands quite a bit off the surface in various places. I just kind of wanted to machine this down and have as few low spots or voids or anything as possible. All this extra buildup will be more to machine off, but if I gotta stop every 5 minutes and fix little pinholes and everything, it's just gonna take really a long time. This guy's really hot still. Yeah, needless to say, I'm not touching that. Oh, and I was using my low alloy filler wire. This is the ER80 SD2. It's considerably stronger. If you've seen my weld strength comparison video, this stuff was several times stronger than normal mild steel filler wire, so that's what this all is. I wanted these joints to be as strong as possible, but these are also all the edges of the hammer, so if and when it does get dropped, it's less likely to incur damage where it's going to land on the edges. One last thing, before I machine all these surfaces, I'm just going to hit it with the angle grinder, especially these big built up areas at the end here, just to try to knock down how tall they are. It'll just save me, you know, 1 or 2 passes on the milling machine for every single surface, so that'll add up. Alright, so since the hammerhead has no precisely machined surfaces, I'm going to rest it on these are just some cheap angle blocks. They're all the same thickness, so I figured it should work fairly well. This will rest on the relatively flat part of the hammerhead. The welded portion will kind of be on the borders of it. That'll allow it to sit relatively flat, and I'll be able to mill the top of it actually flat, and then I'll be able to flip it so the flat side is on the bottom, and that'll give me, you know, a precisely machined surface to work off of, basically. This bad boy's getting really heavy. This weld buildup is a problem, so I've got this is just some aluminum filler metal for TIG welding. It's about 1/8 of an inch thick, 3 millimeters, and I'll just kind of stick that right against that area and then clamp it down. I already have one on the other side here, so that'll kind of grab that area and it will allow me to clamp on that irregular surface, hopefully well enough until I can get some flat surfaces on this thing. Once I get this whole hammerhead squared up, at least these large flat surfaces all squared up with each other, then it'll make everything much easier. I'll be able to basically derive all the other angles from these large surfaces. So I'll probably face off the ends too while I'm at it, while I have it all together here, but we'll see how straight I can get this first. Alright, this is my 3rd time milling anything, and the first time milling something for real. If I screw this up, I'm totally screwed. But let's see how it goes. Wish me luck. Just thought I'd show you here. I finished milling the top surface, nice and flat now. You normally can't see this, but I've got a bright light shine on this right now, and this is the edge of the weld. You can actually see it's it's kind of a shinier finish basically. Once I finish this for real and I sand this all down, it'll look fine. Alright, so I thought I'd give a little lifting demonstration here. This thing's gotten really too heavy for me to lift. I'd estimate it 140 pounds or so, and you can see I kind of have to lift it from fairly far away. You can't get super close to it. Furthermore, I don't really want to drop it on any of these nice machine surfaces or ding up the jaws or eventually ding up these nice machine surfaces on the hammer itself. So this is an engine hoist, and I've got a magnet on it. This is, you pull this lever and it can lift 1,320 pounds, 600 kilograms or so, and I'll just grab the magnet, flip it over manually, and then use this to set it back down gently. I'll demonstrate really quickly here. Alright, so I got all four sides flattened out, and I measured, and there was only 0.010 of an inch difference between the widths of the two, opposing sides. It's only 1/4 millimeter or so. I did make one finish pass. We're now within 0.002 of an inch. It's like half a sheet of paper basically. So I'm calling it good. Interesting little side note about machining. I've made 2 passes, and you can clearly see the line, and it looks like a ridge, but it is not, or at least it doesn't feel like it. I can run my finger over it and I don't feel any difference. Even my fingernail doesn't catch on anything. Now let's do something a little more adventurous, and let's see if I can face off these sides with the block oriented just like this. I'm not sure that's going to work. I may ruin a tool, but I think it's the best way to square up this end with this end with this end. Maybe. Alright, so you can see what I'm going to try to do here. This cutter is pretty much exactly as long as I need it to be. So I'm just going to feed the workpiece that way. I'm taking the tiniest little cut, maybe 0.010 of an inch, 1/4 millimeter or so, and I'm just going to hand feed it here, and we'll see what happens. It'll take a couple passes, but I'm not sure if this is advisable or not, so I am wearing my full face mask, and I'm going to be standing off to the side, so wish me luck once again. This part is going to need a little lip. It's going to be cut about 1/16 of an inch deep, and that's about 1.5 millimeters on all 8 faces on each side. Once I have that lip in there, then I can measure from the lip to the end and decide if I need to shave more off one end or the other. That should work. Alright, so I've been cutting these slots, or rather this lip, on all 8 sides, just a little 1/16 lip. You can see it here and everything, and I've run into the first, I'm not calling it a failure, but I just didn't fill in enough area. There's kind of a little divot right there, so I'm gonna clean that up really well and just TIG weld, fill it all in, and then just recut that area. I'm going to weld it right here on the milling machine. TIG is pretty clean, so I'm not going to get spatter everywhere. And it's actually in position to make that cut. I just made it, so it'll be easy just to fill it in and then quickly make a pass, and I'll be all set. Oh, and to easily maintain all of these lips being in exactly the right spot, I've actually got a stop over here. So every time I got to flip this in the vise, I just press it right up against this stop, and then my cutter is automatically in position for the next side. So I did all 8 sides in maybe an hour or so, which is not too bad. You know, I just want to take a few seconds to lay out how much of a pain this can be to set up. I had to configure this in such a way that I could clear the machine. You can see I just made a cut, and you can see how that's really close, and then the nuts just barely clear that right there. It doesn't actually look like they will, but they do. I had to cut these down, and I had to make this clamp and everything, but it just barely clears. It took me 2 hours to set that up to cut, and maybe 20 minutes to do all the cuts. Oh well. Alright, so we've got almost the entire thing done. All of the surfaces of the machine. We've got this lip all the way around, and it's nice and even. As you can see, top and bottom surfaces are flat. We just need to cut these angles. Now these are all the same. So what I'm actually going to do is I'm just going to tilt the head of the machine. You can kind of see there's a little protractor of sorts. I'm just going to lean it back at the correct angle, make a pass this way, flip it in the vise, make a pass, flip it in the vise, make it a pass, so on and so forth. Got to do 8 sides, and then I got to figure out how to do these little guys. Here we go. Easy enough. We've got the markings here. 27.5, more or less exactly. Actually, looks like it's a little higher, but 27.5. I think I'm calling it good. Alright, I'm just doing a test cut of this corner. We're looking pretty good here. I have the rest of them to go, of course, but I just wanted to show you my little setup here. I've got a V-block against this unmoving jaw, and I've got it clamped over here on this flat. Not a ton of, you know, square footage of clamping. That's not too bad at least, but this makes me a little nervous, so I'm going to take some pretty mild cuts. Alright, boys and girls, we are on, I think, day 4 of milling this. As you can see, we've actually got it all done. The bottom is done. All the angles are done. I'm happy with the way everything lined up. All the measurements of all these sides look pretty good, except if you're familiar with this hammer, it's a little too tall. This section right here is too tall. I'll actually show you with the prop hammer real quick. Yeah, this should give you a pretty good example of how much taller it is. Not a huge amount. If you remember way at the beginning, I used 1/2 inch thick plates, about 12.7 millimeters, on the end caps here. And the reason for that is I had steel that was almost exactly the right thickness, but I wanted to give myself a little bit of a buffer room. So obviously this came out too tall. It was more or less intended, and now I'm just going to mill off the top something like 1/4 inch or 6 millimeters or so, top, and then flip it over and do the bottom, and we should be pretty much right where we need to be. Alright, boys and girls, I think that's about it. It's just about 1 in the morning. Finished up all the milling. Still really hot from that. But I would say it looks pretty damn good. Tomorrow we'll get started on the etchings and so forth on the end caps, but I'm going to bed. Okay, so if you've ever tried to put down a vinyl template for an etching, you'll know that placing it is a nightmare. Now, I have 4 of these to do on each end of this hammer, which is even worse because I need the placement to be consistent. Otherwise, you'll be able to notice, you know, from panel to panel, if they're different, it'll be obvious. So, one advantage to machining this is that I've got consistently sized faces. All 8 of them are more or less the same, within a few thousandths of an inch, you know, less than the width of a human hair, basically. So that allowed me to consistently make the vinyl templates that will match, and I won't have to make separate ones for each. They're all exactly the same size. And just to make my life a little easier, I designed them with this little 1/8-inch border around the edge, and that allows me to precisely just kind of place these, and the border kind of fills out the spacing, and it will allow the design to be centered perfectly with basically no effort. I just have to line up the edges of this with the faces, you know, I mean, everything pretty much lines up perfectly right here, so just place it on there and they'll all be relatively accurate. Alright, we are nearing the moment of truth here. I've let the nail polish dry for about 4 hours. This is the power from the DC power supply that I'm going to use for the etching. I've taped it in numerous times to try not to let any water in there, but it's probably going to happen anyway. So the bare end of the wire is wrapped around this hole, because if the electrolyte gets in there and this area gets etched, it's not a big deal. This is going to be where the circular top plate is going to be with all the runes on it. So if this area gets etched, it's not the end of the world. I've got the wooden dowel going through here, and I've glue gunned both sides of it. This is what I'm going to use to lift it, and the glue gun just kind of seals that off so I don't get the inside of the hole etched as well, which would make the handle fit sloppy. So really trying to avoid that. One final note, as I may have discussed earlier, I have had some issues etching angled surfaces like this before. It seems like there's a buildup of bubbles on the top surface, and that part seems to actually etch faster for whatever reason, but it gets more pitted as well. In order to combat that, I'm hoping to agitate the water a bit. I bought this little guy. This is a fish tank bubbler. It should hopefully have some pretty good circulating qualities. Maybe that will help keep any kind of buildup from forming on the surface here. Maybe it won't. I don't really see any downsides, but I might as well try it. The better etch I can get, the better this is going to turn out. I've only got one shot at this. Oh, and if you think etching looks easy, know that to get this hammerhead to this point, it's been about 6.5 hours between, you know, fitting the decals and cutting them and so on and so forth, making all 8 of them. I actually made 10 just to have enough. The multiple layers of paint, all the planning out, the sacrificial steel and everything, planning how I'm going to move it. Pretty much an entire day, and I haven't even done any etching yet. Well, there we go. I've got the bubbler going. Seems to be agitating the water pretty well. I made sure that sacrificial piece of steel isn't actually touching any of the exposed metal. I'm actually not sure what would happen if that did happen. I assume it would just short out. Alright, so I have just taken it out of the salt water. I originally intended to etch it for 30 minutes at 2 amps. I increased that to 3 amps and 2 hours. It just didn't seem to really be etching, but there's quite a lot of area to be etched, and multiplied by 4 times, so it looks okay at a glance. I don't know how deep it is. Okay, well, here's the first one uncovered. I'm not even really sure what to say. It's nearly perfect. And look how smooth the background is. The etchings are nice and sharp. I guess the only problem I see, there's one little tiny pinhole right there. And it looks like this top part, it's just kind of, it etched obviously because you can see the border right there, but then it must have just stopped etching. A little bit over there too. Nothing on the left. Bottom looks basically perfect. I think I can work with this. I've been welding and grinding and machining, trying to get every little defect out of this thing, and so I did kind of a finish sanding just to make sure that, you know, the roughness of the finish wasn't hiding any grossness basically. But I think we're pretty good. I've marked out the stripes on the bottom and the sets of stripes on the sides. Obviously this is just a rough kind of outline. I will do it a little more precisely on the mill, of course. I just kind of like to have the marks as, you know, a sanity check basically. Alright, so in today's episode of I have no idea what I'm doing, I need to make a little 1/16 line on each side of the hammerhead. It's 1.5 millimeters, and it's going to be the same depth as well. Now that's pretty damn small, so I'm using this little tiny cutter. It's got a 1/16 inch cutter and an 1/8 inch shank, and it's solid carbide, which means I'm probably going to break it off within the first 3 seconds. I did buy a bunch of them, so I got a couple shots at this. If it doesn't work out, I'll just do it with a Dremel or something like that, but I would prefer the nice, precise, straight lines of the milling machine. But I'm going to put on some real face protection just in case, because this thing's going to have to spin at a couple thousand RPM, and when it comes flying off, it's a little thing, but I really don't need that stuck in my cheek or something. One final note here, one of the reasons why I'm fairly nervous is this is an older machine. It's from 1963. The highest speed it can go to is 2720 RPM. Now, I have the motor hooked up to a variable frequency drive, which means I can over and under drive the motor pretty much as I want. Now, I've heard that I can double the speed. I'm a little nervous about that given how old the motor is and how expensive they are. So I'm just going with 50% more. So I'm going to hit this at about, I think, 4,100 RPM, I'm just estimating. Contact! Alright, so this part's a little tricky. I don't know how well you can see this, but I need to line up that angle between the two sets of lines. So I measured it, I got it close, it was 36.5. Then I just kind of fine-tuned it manually. What I do is I just kind of plunge it right into the edge of the last slot, and then I just test it by kind of doing a dry run. And that's it. It's right on the edge of that slot. We are good to go. Well, here we are. It's not too bad, I would say. The bottom corners came out, I mean, basically perfectly. The top corners have a little bit of a rounded edge. That one's actually a little bit worse. I'll use a little file work and get that out of there though. I mean, I'm really zooming in here, so I think it looks pretty damn good. Alright, here she is, hot off the milling machine. I'm extremely happy with the results. I really can't believe how well this came out. I think I'm basically done. I do have to do a little bit more sanding. I don't know if you can really see, but there's all kinds of little scuff marks from the V-block and the vise and everything. I covered the whole thing in painter's tape, but it's just so heavy that even moving it on a machine surface or clamping it down still produces some effects. But I mean, I can't even feel that. It's just a little bit of finish sanding. I do want to kind of finish off these ends here. They're rounded because the end mill is round, obviously. I'm just gonna use a little narrow belt sander and just clean that up a little bit so it's more squared off. You know what? Let's get that handle and test fit it. Let's see how it looks. Let's try this out. That is really tight. I had to mark that and trim it to fit, but oh man, look at that. I cannot wait to finish this up. This is going to be incredible. The handle fit is almost perfect. I don't know if you can see this. That's how much I can move it. Just wiggle the end of it a little bit. Alright, so what I'm going to do here is I'm going to use a little bit of 5-minute epoxy on the handle. Just mainly the positioning tool. I need to get the little arrows on the handle lined up, you know, lengthwise on the hammer basically. And I also want to clamp it so that it seats as strongly as possible here. Later on, once that sets up, I can flip it over and I can weld it. It would just be such a pain to try to clamp it, position it, and weld it all at the same time. Plus the epoxy will kind of ensure that there'll never be a rattle or anything like that. It'll fill that tiny little gap between the hole and the handle. So, win-win situation. Alright, can't be too careful, so I actually went to dinner and I let the whole thing set up for a couple hours, so I'm pretty confident to stay in there now. I'm just going to preheat this with a MAP gas torch, and just to ensure as much penetration as possible. This orange stuff is actually anti-spatter spray. You'd use it on the inside of your welding gun and so forth. It actually works well for situations like this. Alright, let's get this bad boy weighed. $134.4. Not too bad. Alright, so one last quick test. I wanted to make sure the leather strap will actually hold the weight of the hammer. I'm really not sure if it will. I made an extra one just in case, but I figured I'd test it before somebody drops it on their foot. Let's try it out. I can't even lift it like this. Alright, I'm going to have to attempt this on the ground because I'm literally not strong enough to lift it by the strap from the table, so. Oh yeah, no problem. Pretty strong leather strap. Alright, I've got no battery life left. 2 minutes. No time like the present. Let's lift this bad boy. Don't ever lift heavy weights with no warm-up. It's really stupid. This is really stupid. I'm going to use gloves because it's very slippery and it's still very hot from welding it. Here goes nothing. cramp my lat. Oh. Don't do that without a warm-up, ever. Oh my god. Alright, now I know I'm going to get a lot of questions, so I figured I'd just preemptively answer them right here. You're wondering, hey, I lift weights, how easy would lifting that hammer be for me? Now, I will say, from my own stats, I am 6'3", about 230 pounds. I've been powerlifting for 7 years. I've got a strict military press or overhead press or shoulder press or whatever you want to call it. Strict standing military press of 200 pounds, and my best bench press lately is 335. Now, I did the 1 rep with no warm-up, as you saw. That was brutal. And then later on, as part of my actual workout, I think it was the next day or the day after that, I did 3 reps, and that was, again, pretty much as I could manage. It doesn't seem like a lot, 3 reps with 135 pounds. I'm sure if you've been lifting for a while, you could do that easily with a barbell, but it's just the weight, the balance of the thing, the awkwardness of it, the fact that even if you two-hand it, you got to have your hands really close together, and it's really hard to exert force like this, you know what I mean, and then get it over your head. Your shoulders just don't really want to do it. You got to have your arms out way in front of you, which increases the leverage and makes it much harder. With the barbell, you can really get, you know, almost in line with your feet, basically, straight up and down. But with your hands close together, you're doing like a front raise or something like that, basically. Much harder to do, as you saw in the videos. Now, I also had my heterosexual life partner, Butts Kensington, attempt this lift. He is a giant Viking, and he's approximately 6'5" and 300 pounds. He's got a standing strict military press of 275 pounds and at least a 400-pound bench. Now, as you can see, he was able to press this overhead and then hold it with just one hand, which was absolutely lunatic. I wouldn't even attempt to do this myself. I suspect that body weight and size plays a factor, especially due to the size of your hands, just to be able to try to balance the thing and hold it steady. Because even with 2 hands, you saw it wants to just kind of rotate immediately and drop right into your face. Now, this is the fake hammer. This is just a plastic replica, but it's the same exact size. So if you saw this and you said, "Oh, this is solid steel," it'd be pretty heavy, but I don't know, 60, 70 pounds, maybe 30 kilos. It wouldn't be that crazy. So when you see me lifting it, I'm sure you're thinking, hey, like doesn't look like anything. It's not a big deal. But I did look up for a practical comparison, and the average stove, kitchen stove, weighs 128 pounds, I looked up, which is 7 pounds less than the hammer. So just try to imagine lifting a stove above your head and how awkward it would be to balance it and everything. And you kind of have an idea of how ridiculous it really is to lift. The stove actually might be easier in some ways because the stove would be wider and you could really get your lats into it, your shoulders into it, even your pecs and everything. But of course, since it's so big front to back, it would be very tough to balance that way. Just to give you a very basic idea of a common household object that weighs less than what the hammer weighs. Now maybe you have a little more of an idea of what it takes to lift this thing. If you are interested in trying to lift this hammer yourself, it will be on a promotional tour around the United States, probably this summer and fall of 2018. If appropriate, I'll post links to where it's going to be. If you're curious, just ask me on Facebook or Instagram or whatever, and I'll see what I can dig up for you. Well, boys and girls, this is it. I wish I could show this to you in some natural lighting, but it's late and I'm shipping this tomorrow morning, so I pretty much don't really have a choice. This is what you get for now. I did get some professional photos taken, and I'll probably append those at the end of this video or something like that. This is all just wax, by the way. I'm literally preparing to ship it right now, so I'm putting a heavy coat of wax on it for rust protection, and that's it. But I think you get the idea. It's a heavy mother, that's for sure. I've probably picked it up about 100 times, just moving it around and so forth, and it surprises me every time. But there you go. Alright guys, that's it. As I said in the intro video, I appreciate constructive criticism. Send me messages on any of my social media sites, and let me know how awful a job I'm doing. I appreciate it a lot. Now, one of the most common comments I get is basically, why is your channel not bigger? You know, why aren't there more people watching you? I mean, I think my videos are awful, so I'm shocked that there's 1,500 or so subscribers right now. It's actually way more than I ever expected. I figured, you know, 100 or 300 or something like that was going to be, you know, my peak. So I'd say I'm doing pretty well compared to my expectations. But if you did like my video, the best way you can really help is to give me a like, a subscribe, and share my stuff wherever, message boards, Facebook, Instagram, wherever you feel like it. Till next time, guys. Thanks for watching.